Hey, grade sevens, I'm back. Hopefully you can see the whole screen this time. I don't know what was going on with those other videos I made, but I think we've gotten past it. So we're on section 8.4. So you've done 8.2, which was on diameter and circumference of circles, and 8.3, which was on area. Those are very important sections for this unit, especially, being able to find the area of a circle is definitely a necessary math thing that you need to be able to do. So make sure you go over that. If you're still a little bit confused, we'll do one example question at the end of this. But we are going to be looking at this section 8.4, which is just interpreting circle graphs. So looking at circle graphs, so it doesn't really have to do with area or diameter circumference at all. We're going to be more looking at using our percents again, which we did a while ago. And then be able to just see and look at circle graphs and assess them and see what they're telling us. So what is a circle graph used for? A circle graph, since it's like in the shape of a pie, it shows you parts out of that whole circle. So we're comparing parts to the whole. Okay, that's the basic 4-word explanation of what circle graphs are used for. They're used for comparing parts of something to the whole of something. So, for example, in the circle graph that we have here, we are looking at Mr. Wong's class. So that's the whole. His whole class is the whole, and there are 24 students in that. And then we're comparing the parts of it. So the part that likes or that has cats as pets, the part that has dogs as pets, the part that has no pets, the part that has some other animal. And so we can compare them, and we can easily visually see which group has the most, the largest percentage in that group without actually even looking at the numbers sometimes. It's just quite easy to compare. It's easy to see, oh yeah, cat has more than other. Dog and no pet are the same. So they're just a good visual when comparing. So there is some necessary information that will be involved in a circle graph. The first one is a graph title. So you have to have a title explaining what the graph is showing. It's amazing how many times in the news and sometimes in newspapers and stuff, they'll show a circle graph, but they actually won't have a descriptive title, and you're not actually totally sure what you're looking at. So in this case, title can be simple. It's just pets of students in Mr. Wong's class. So that's the title. It's descriptive. It gives you information about what the graph is showing us. The second thing you have to have is the total number. Total number. Okay, and the total number here is the 24 students. Now you need to show that because that allows you to find some more detailed information from what the actual circle graph is showing you. And it also gives you, like, we don't know if maybe Mr. Wong's class only has 8 kids or something, and then that tells you something else. So it's important to have that in there. That has to be in there, the total number. You have to have category labels. Okay, so the category labels here are just cat, dog, no pet, other. So you have to have those labeled. You can't just have the percentages, but you also need percentages. Now, usually it's nice when a circle graph has big enough pieces and few enough pieces that you can write all of these inside the circle. But sometimes you'll see, there'll be really little small pieces and you can't really fit it in. And sometimes they have a legend beside and they'll have whatever color there, and they'll say that color is dog. And they'll have all that information beside, 15%. And it's fine if it's beside it as well. That still shows that same information. It still has that category label and the percentages. It's just not inside. But circle graphs are generally, they have the information inside of them. Okay, so those 4 things you have to have: graph title, the total number of whatever you're looking at. In this case, it's students, but it could be other things. Your category labels and your percentages are all necessary information. So let's look at a few circle graphs. Okay, so this circle graph shows how Omar spends a regular weekday. Okay, so what's our thing, our total thing that we're looking at? We're looking at a day. So one day, so we're comparing parts of his whole day. He has the total number of hours in the day, so we're comparing hours this time, not number of students, but number of hours. So there's 24 hours in a day, so that is true, that's correct. He has the labels in each section. Eating had to be outside, and that's okay, just didn't fit. And he has the percentages, so he has everything that's necessary for an informative circle graph. So now we can answer these questions. So what activity does Omar spend the most time on during a 24-hour day? How many hours does he spend on this activity? Okay, well, we can look at our graph, and you can right away see that, well, either school or sleeping has the most. And if you weren't quite sure, that's why there's the percentages, so we can see that sleeping has 35%. So he spends the most time sleeping. Okay, and it asks how many hours does he spend doing that? Well, our circle graph doesn't like clearly say how many hours he spends doing it. It just says what percentage of his full day he spends. So you have to go back. You have to remember using percents and finding a percent of a number. So we're trying to find 35% of what? Well, 35% of 24 hours. Okay, so now you're going to have to do a bit of a calculation. So 35%, remember, is the same as a decimal. It's the same as a fraction too. It's the same as 35 out of 100. Percent means per 100. Of means times. Times by, and then 24. So hopefully you sort of remember this. This might be a bit of a review, so you might need to watch this part a couple times. So of means multiply. 35% is the same as that fraction. Well, that fraction, 35 over 100, we can just go 35 divided by 100, and that gives us our decimal, which is 0.35. So we have 0.35, so that's less than 1, which is good because 35% is less than 1 whole. 0.35 times by 24, and that gives us 8.4. Okay, so 8.4 is 35% of 24 hours, so he's spending 8.4 hours sleeping. Good for Omar. That's a good amount of sleep to be getting. So how many hours, so we're on to B here, how many hours, so not what's the percentage, but how many hours does Omar spend at school and doing homework? Okay, so I'm just going to erase this. If you need to watch that part with the sleeping again, you can just click back on the thing, rewind. So how many hours does Omar spend at school and doing homework? Well, school and homework totals up to 30% plus the 10%. So in total, that's 40% of his day is school and homework. So 40% of his day, how many hours is that? Well, that's 40% of 24 hours. Okay? So you might even, I'm just going to quickly review doing this mentally. So some of you might remember doing this. So like if we were finding 100% of 24, well, 100% of 24 would be 24. Well, 50% of 24 would be half of 100%, so that'd be 12. Okay, what about 10%? Well, 10% would be 100% divided by 10. 24 divided by 10 is 2.4. Okay, and then 50% minus 10% would be 40%. So I could go 12 hours minus 2.4 hours. Whoa, my speaker did something weird. 12 hours minus 2.4. Well, 12 minus 2 is 10. Minus 0.4 is going to give me 9.6. So 9.6 hours is how much he's doing school and homework. Ooh, that's a lot of a day. So that's one way. I just did that mentally. I didn't pull out a calculator to multiply by decimals or anything. So we did go over this back earlier in the year. So maybe you remember that. Just trying to refresh your brain with some of this stuff. So that is one way you can do it, is mentally, but I will show you, you're allowed to use a calculator. So if we're trying to find 40% of 24, remember that of means multiply. So we have 24, which is just a number. 40% we turn into a decimal. So 40% is 40 divided by 100, which is 0.4. And now I have 0.4 times by 24. So then you can just take out your calculator. Finding my calculator. And I mean, I already found the answer, but I'm going to do this again on my calculator to show myself that it's still giving the same answer. 0.4 times by 24 equals 9.6. Okay, that's the same answer that we got before doing it the other way. But you can also, this way is a lot easier. So you just take your percentage of whatever your total is, you turn your percentage into your decimal, and then you just multiply by your total. So he spends 9.6 hours at school and doing homework. So what percentage of his day is spent eating? So the eating section there is unknown, so we need to figure that out. But we do know that a circle always adds up to 100. So 35% plus 10% is 45%, plus 30 would be 75%, plus 20 would be 95%. So to get to 100%, we can only have 5% more. So he must spend 5% of his day eating. Okay, and that's that. Next question. Okay, so just a quick review of the key ideas of this section. So a circle graph shows how each category of data compares to the whole. So comparing to the whole is the important part, and we use percents. So that has to have percents in there. So the sum of all the percents in a circle graph is 100%. This is also something that sometimes people make graphs and it doesn't add up to 100. You'll see it on Fox News or other places sometimes. They just have the circle graph, but it's confusing what it's showing because it adds up to like 200% or something. So circle graphs are easier to interpret when there are a small number of categories. So if there's too many, then there's too many little pieces and it's hard to read it, hard to compare. And when the percent values are not too close together. So if all the pieces are very close to the same size, showing it in a circle graph is fine, but it doesn't give you a good visual representation because you're really just having to look at the percentages anyways, in which case you don't need to make a circle graph to show the visual comparison. Okay. A couple more questions. So which set of data, keeping in mind those key ideas, should not be represented by a circle graph? And why not? Okay, so we have Madison's monthly spending. So the amount of money she spends in a month. So that's looking at a total amount. So there is a total, her 1 month spending. And that month spending we see split into lunches and snacks, entertainment, savings, and other. And 40% plus 30% is 70, plus 20 is 90, plus 10 is 100. So this adds up to 100% of her spending. And so we can see parts of her spending, of her whole monthly spending, and we're comparing those parts. And so this is a good situation to use a circle graph. You're comparing parts to a whole, the percentages add up to 100%. What about the second one? Eric's math test results. Well, we're looking at a bunch of different chapters here, chapters 1, 2, 3, and 4. And so we're not really comparing it to a total. We're just comparing different tests. There's no whole amount here, right? So Madison's monthly spending was the total amount he spends in a month. This doesn't show his total amount of tests or his total percentage in his class and where those percentages came from. It just shows his chapter test marks. And 75% plus 77% plus 80% plus 80% adds up to way more than 100%. So this information, Eric's math test results, while it could be valid data and useful information, it isn't going to be used, or it shouldn't be used, in a circle graph. We'll talk about this in grade 8, but you would use a bar graph for that. Okay, and then, is each circle graph correct as shown? If not, what needs to be changed? So in these two circle graphs, is there anything in either of them that needs to be added? So let's think of when we think of our checklist, It needs to have a graph title. It needs to have a total number. It needs to have category labels, and it needs to have percentages. So let's see if these graphs have that. Whoa. What? Okay. Okay, so this has a title, Students in the Club, but it does not tell us the total number of students in that club. So there's some missing information. So we couldn't know. We might see that, sure, 25% are in grade 7, but we don't know how many actual grade students there are. We can't calculate that. So there's a bit of missing information, but they have their category labels, grade 7, grade 8, grade 9, and they have their percentages. And do the percentages add to 100? Well, 35 plus 40 is 75%, plus 25 is 100%. So yeah, all of those add up to 100%. Okay, in B, we have grade 7 favorite sports, valid title, but again, they're missing the total number of grade 7 students. And then we have these different titles: soccer, hockey, basketball, volleyball, rugby. Okay, right, as of now, looks good. But when we look at the percentages, 25% plus 25% is 50%, which is half. So it makes sense that that would make up half of the circle. But then basketball, volleyball, and rugby says each have 20%. So 20% plus 20% plus 20% is 60%. But 60% is still, even though it's more than half, is still only taking up half of the circle. Well, and then when we add up all of these percentages, we see 25 plus 25% is 50. 50 plus the 60% is 110%. So somehow this is showing information for more grade 7ers than there are, because 100% is all of the grade 7ers. It's impossible to have 110% of the grade 7ers in a school, because you can't have more than what there are. So this one, the percentages are off somewhere, so that would need to be changed as well. Okay, so just comparing, just looking at circle graphs, that's about all there is. Just review the key ideas, review what needs to be in the graph, and you definitely will need to either go back and remember, or just watch this a couple of times, finding percentages of a number, right? Like finding 20% of 24. Maybe pause for a second, see if you can find 20% of 24. Okay, you're unpaused. Did you get the same answer as me? Well, 20% is the same as 0.2. Of means multiply 0.2 times by 24 gives you 4.8. So that should have been your answer. Okay, just quick review on circles and area. So going back to the last section. So we have a, whoops, I'm going to change this. We have a circumference. I want to call this a circumference. The circumference is 120 centimeters. So if the circumference is 120 centimeters, what is the area? Okay, well, let's just quickly remember that area is area of a circle. What's the equation? Pi r squared. Okay, so pi times by r times by r squared, r times r. So that's our equation. So the information I need, I know what pi is. Pi is 3.14. But I don't know what the radius of this circle is yet. So I know that the circumference, so the measurement all the way around my circle, is 120 centimeters. Well, from circumference, what information can I find? Well, I know that my diameter goes into my circumference 3.14 times. That's that pi. I know that the equation for circumference is pi times by diameter. So if I wanted to find diameter by itself, I could divide by pi and divide by pi on both sides to get the diameter, the dl by itself. The pi's cancel out. So c divided by pi is equal to diameter. So I can take my circumference, 120 centimeters, and I can divide it by pi. So 120 So diameter is equal to 120 centimeters divided by pi. I'm going to use 3.14. 120 divided by 3.14. And it gives me this number with lots of decimals. I'm just going to round to the nearest. I'll just keep it to the third decimal place, the nearest thousandths to be quite precise. So 38.21 and then 65. I'm going to say 217. Okay, so 38.217 centimeters would be the diameter. The radius is equal to half of your diameter because diameter goes all the way across. So all the way across would be 38.217 centimeters. So my radius from the center just to the outside would be half of that. So diameter divided by 2 is radius. So 38.217, I would divide by 2. And I get, I actually just kept the whole number without rounding in my calculator, but I get 19.108 centimeters is my radius. So if that's my radius, now I can use this and put it into my area equation. So my area is equal to pi 3.14 times my radius, 19.108 centimeters, times by radius again. R squared is radius times radius, 19.108 centimeters. Take my calculator. You are definitely allowed to use your calculator in this unit. 3.14 times by 19.108 times by 19.108 gives me this big number. And this is what's surprising with circles. They actually have pretty big areas. So the area here is 1,146 point, it says 46, I'll just go to the nearest tenth. 1,146.5 centimeters. Since it was centimeters times by centimeters, we say centimeters squared is our units. Okay, and this is the area of our circle. So really important, finding area. You just have to find the radius. Now you might need to do some calculations like I did over here to find that radius, and then you just remember that r squared means radius times radius. Not radius times 2, radius times radius. Okay, and you can just use 3.14 for pi. If your calculator does have the pi button, you can use it. But 3.14 we will say is exact enough for now. Okay, that is it, grade 7s. I will see you later. Let me know if you have any questions.